point 3 is on multiplying fractions. I believe you'll like this section a little bit better than the last one because when you multiply fractions, you don't have to have common denominators. You don't have to rewrite your fractions so that they have common denominators. You can work with them as is. So to multiply fractions, remember, A over B times C over D is A times C over B times D, which is just saying you multiply the numerators, you multiply the denominators. And of course, the denominators, neither one can be 0. Now, there's also a simplification step that you may remember called cross-canceling that you can use. I'm going to show you that here as I work some of these problems out. So I have two fractions, two proper fractions. One's negative, one's positive. Of course, when you multiply a negative times a positive, it's negative. So I already know my answer is negative. And here's where the cross-canceling comes into play. I could multiply the numerators, 33. I could multiply the denominators, 60. And write this as 33 over 60 and then simplify to lowest terms or to simplest form. But what I can do is I can kind of avoid the bigger numbers by cross-canceling early on in the problem. If you have a factor from one of the numerators and one of the denominators, now it's called cross-canceling because most of the time it's kind of on this little diagonal of the numerator of one, the denominator of the other. But they can be in the same fraction. You could have a numerator and a denominator top and bottom like that that might cross-cancel or simplify. And you divide or cancel that factor out. I have a factor of 3 and a factor of 3. 3 goes into 12, 3 goes into 3. 3 divides into 3 one time. 3 divides into 12 4 times. By doing that, the numbers become a little bit smaller. Now I'm going to use the rule. I'm going to multiply the numerators, that would be 11. I'm going to multiply the denominators, that would be 20. And my answer is already in simplest form. Now, if you don't see to cross-cancel, if you miss that step, and it's there, but you just miss it, don't worry about it because when you get your answer, you can still simplify your answer. I notice here 11 over 20 does not reduce anymore. Now, part B here, this is the same thing as saying 7/8 times 7/8. So you multiply the numerators, 49. You multiply the denominators, 64. You have 49/64 as your answer. It does not reduce. Nothing cross-cancels. That's it. Notice that when you square a fraction, you're just squaring the numerator. You're squaring the denominator. Now down here, I have another negative times a positive. So I know right away that that's going to be negative. And I have two things I can cross-cancel. I have a 3 here and a 12 here, like I did in the first one. 3 divides into 3 once, 3 divides into 12 4 times. But on here I have a factor of 5. 5 divides into 5 once, 5 divides into 10 twice. So when I get done cross-canceling, I'm multiplying 1 times 1, which is 1, and I'm multiplying 4 times 2, which is 8, and my answer is negative 1/8. Now, the last example that I have there is extra special. You don't find this in a lot of algebra books, but I'm going to show you a trick here where you can take a fraction that's raised to a negative exponent and be able to deal with it. Because what happens is the fraction raised to the negative power is the same as the reciprocal of the fraction. That's where you make the numerator the denominator the numerator. So instead of 2 over 5, now I have 5 over 2. And you change the sign of the exponent, in this case, from a negative 2 to a positive 2. Now the problem looks a little bit like the problem there in part B. You're squaring a positive fraction, 5 over 2 times 5 over 2. Remember the shortcut? You square the numerator, you square the denominator. 25, 5 squared, 2 squared is 4. Now I'm going to go ahead and write this as a mixed number because my answer is improper. 25 over 4, 4 goes in 6 times with 1 left over, and there's my answer. So if you have a fraction raised to a negative power, you can write the reciprocal of that fraction raised to the opposite, to that positive power. All right, now, notice here, no mixed numbers, no integers, just fractions, just proper fractions. Well, this one ended up being improper, but other than that. When you are multiplying, if you have integers and you have mixed numbers, change them to improper fractions. You want everything in fraction form, okay? So we'll show you some examples of that. Okay, the first problem I'm going to do is got an integer, 10, and it's got a mixed number, negative 2 and 3/11. I'm going to write both of them as improper fractions. And as I mentioned, anytime you have an integer, if you want to write it as a fraction, just put it over 1. So I'm going to write this as 10 over 1 times, now here I have a negative. 11 times 2 is 22, plus 3 is 25 all over 11. Now nothing cross cancels here, and I know there are 5 divides into both of those, but they're both in the numerator, and one's got to be in the numerator, one's got to be in the denominator. You can't cancel straight across. So I can't simplify, I can't cross cancel. I have a positive times a negative, that's negative. I'm going to multiply my numerators, that's 250, and then I'm going to multiply my denominators, that's 11. Now because my answer is an improper fraction, I'm going to take that extra step and I'm going to divide. I'm going to be careful because I'm going to try to do this one in my head. 11 and 25 is 2, so that'd be 22, 30, that'd be 2 with 8 left over. I better double check that one. 11 into 250 goes in 2 times, that's 22. Goes in 2 times, it's 22 with 8 left over. It looks like I've got that one right. And because a positive times a negative is negative, I write this as negative 22 and 8/11. The next one is a negative times a negative, and notice another integer, so I'm going to write that as negative 14 over 1 times negative 8 over 21. Here I can cross cancel. By the way, negative times negative is positive. The 14 and the 21 are both divisible by 7. 7 goes in twice there, goes in 3 times there. So I end up with a positive 16 over 3, or 5 1/3 when I change it into a mixed number. Now here I have 2 mixed numbers. 23 over 3 times 27 over 10. Well, I can simplify this a little bit because 3 goes into 3 once and 3 goes into 27 9 times. I don't see anything cross-canceling there. So I have 23 times 9, which is not one that I do all the time, so that's 7. Looks like 207, and that's all over 1 times 10, which is 10. Now in this case, because I'm dividing by 10, that's kind of nice. 10 goes into 207 20 times with 7 left over. Keep the same denominator. 20 and 7/10. This one is a positive times a negative, so I know it's negative. I'm going to write this as 33 over 8. 8 times 4, 32 plus 1, 33 over 8 times negative 3 times 1, 3 plus 2, 5 over 3. Well, again, I can do a little bit of cross-canceling here. 3 goes in once, 3 goes in 11 times. So it's negative. Positive times negative is negative. Looks like 55 on top, 8 on the bottom. 8 goes into 55, not quite 7 times. Looks like 6 times, negative 6 and 7/8. All right, my next example, I'm multiplying 2 negatives, so again, it's going to be positive. This is going to be a, let's see, 15, negative 18 over 5, negative 14 over 9. Well, the 18 and the 9 are nice. I can cross cancel there. Divide both by 9. 9 goes in 18 twice and into 9 once. Negative times negative is positive. So it looks like I'm going to get 28 all over 5. 2 times 14 is 28. 5 times 1 is 5. 5 goes in 5 times with 3 left over. And I have 5 3/5 for my final answer there. Now I'm throwing in some variables. This will make this fun. I can work with these right away because I don't have any mixed numbers or integers. And I can look right here. I can cross cancel a 7 into that once, a 7 into that twice. So that's c times 2 on top, which I'll write as 2c, 1 times 15 on the bottom, and that's my answer. Now, it doesn't simplify any more than that. In the next example, I'm multiplying 2 negatives, so I know it's positive. There's my fraction bar, but I see some cross-canceling. 2 into that once, 2 into that twice, 3 into that once, 3 into that 3 times. So I have 1 times x to the third times 1 times x. Well, the 1 times 1 is 1, and x to the third times x, which is like x to the first, is x to the fourth. On the bottom, I have 3 times 2, and that's 6, and there is my answer. That was kind of slick. The next one is a negative times a positive, so I already know that my answer is negative. I'll put the fraction bar down. And I have some more cross-canceling. 4 goes in that once, 4 goes in that 4 times. Look here, 7 goes in that once, 7 goes in that 3 times. So I have 1 times v squared times 1 times v to the third. V squared times v to the third is v to the fifth. And on the bottom, 3 times 4 is 12. And there, all of that is my answer. And the opposite of v to the fifth all over 12. One more with a negative times a positive, so I already know it's negative. And some more cross-canceling. 3 goes in that once, 3 goes in that 3 times. 8 goes in that once, 8 goes in that 2 times. So on top I have 1 times x times 2 times x. Well, the 1 times 2 is 2, and x times x is x squared, so that's 2x squared. 1 times 3, 3 on the bottom, and there's my answer. All right. There's some work involved, but it's not as bad, I think, as the adding and subtracting. Be very careful with your signs, as always. Be very careful with your arithmetic, especially when you're changing improper fractions into mixed numbers. But you'll get better at that with practice, practice, practice.